Students, in the lesson Light, Reflection and Refraction, let us learn the image formation by spherical mirrors. The first one we are going to learn is the concave mirror. In concave mirror, the inner side is reflecting. So we are going to learn the different image formation by these concave mirrors. So we are going to take different position. First one, the position of the object. We are going to take the different position of the object. The first one is the position of object is at infinity. Infinity means very far away. So let us begin. We draw the principal axis. Take the compass and measure 6 centimeters. You may take 5 also. I take 6. Mark C. This is the center of curvature. So I hold the compass at C and draw an arc. This is the concave mirror. The inner side is reflecting and therefore I shade the outer side. This is P. P is the pole of the mirror. Mn, the aperture. Now I have to mark the focus, the principal focus. Now my CF, the radius is 6 centimeters. So half of 6 will be 3. That is my principal focus. So here the principal axis, the concave mirror, I have marked P the pole, F is the principal focus, C is the center of curvature. Now we have to place the object. So object is at infinity, so it is very far away. So we just take the object here. Now we have to draw the incident ray and the reflected ray. So the first ray will go parallel to the principal axis and after reflection it passes through the focus. This is the first rule. If the ray goes parallel to the principal axis, it emerges through the focus. So we draw the reflected ray like this. The next ray, it goes parallel to the principal axis, it emerges through the focus. Okay, so the rays meet here after reflection. So they meet at the focus. So the image is formed at the focus. So the position of the image is at the focus. The size of the image is highly diminished, it's very small, it's a point size. And the nature of the image is, it is real and inverted. Real means, why it is real? Because it has formed in front of the mirror. Okay, and a real image is always inverted image. So we write the position of the image. So for every ray diagram, we write the position of the image. The position of the image is at the focus. Second one, size of the image. Highly diminished. Third one, the nature of the image. It is formed in front and therefore it is real, and for real it is, the image is inverted. Okay, this is my first. Okay, students, we go for the next position of the object, the second one. position of object it's beyond C. Beyond means it's further than C. So as usual, we draw the principal axis. Take 6 as the radius. This is my C. So from here, I draw the concave mirror. Let's draw it once. The inner side is reflecting, therefore I shade here the outer side. This is the pole of the mirror. Now we'll draw the focus. The radius is 6 and therefore the focus is half of it, the focal length. This is the principal focus and this is the focal length PF. Now I have to place the object. Now the object is beyond C. This is C here. I place it behind. Beyond means further than C. Don't take the object too big, don't take it too small also. So roughly I take 1.5 centimeter as the object. Now the rule is the first ray goes parallel to the principal axis, parallel to the principal axis. So it has to touch the object, isn't it? So the incident ray touches the object, it goes parallel, and after reflection it goes through F. So it reflects and goes through F. The next ray, it goes through C. So it has to touch the tip of the object, the head of the object, the point C and the mirror. So connect these 3 points. So when it travels through C, after reflection the ray goes back to C, and here is the meeting of both the reflected rays. So it comes to C, it goes back to C. So the meeting of the 2 reflected rays, at that point the image is formed, and the image is inverted because it is real. It is formed in front of the mirror. We show the denotation of the object as A, B, the head side as A and the down part is B. So inverted will be upside down. We showed it as B dash, A dash. Okay. So the position of the image formed is between C and F when the object is placed beyond C. So let us write all the 3 points. The first one, position of image between, is formed between C and F. Second point, size of the image. You can see it in your diagram. See, the size over here was 1.5 centimeter and the image that I obtained is very small, less than 1. So the size of the image is diminished. Diminished means small. The third one, the nature of the image is, what type nature it is? It's real because the image is formed in front, real and inverted. A real image can be taken on the screen. So with this we finish with the second one, the position of the object beyond C. Beyond means little further than C. Don't take it very far and don't take it very close to. Okay. So I repeat again, the first ray goes parallel to the principal axis. If it emerges, it gets reflected through F. This is always the rule. If it goes parallel, it emerges, it passes through F after reflection. The next ray goes to C. If it goes to C, it comes back along the same path to C. So remember to connect the top of the object, the head of the object, the point C and the point on the mirror. I hope you have followed this. Let us go for position 3. Position 3 is position of the object at C. So we are going to place the object at C. So as usual, we draw the principal axis. I take 6 centimeters. If you're taking 6, take always 6, otherwise you'll get confused. You may take 5 also, you may take 4 also. Draw the mirror, the concave mirror. The inner side is reflecting and therefore I shade the outer side. This is my C. Half of CP, that is the radius, half of that is the focus. So I take, so this is 3 centimeters CF and this is also 3 centimeters. Okay. So the position of the object is at C. So I draw the object at C. After drawing the object, we write it as A and B. The object is AB. Okay, the C is the center of curvature C. So I draw the first incident ray. It goes parallel to the principal axis. And emerges, reflects back through F, passes through F after reflection. Don't forget to put the arrows. This is the incident ray. This is the reflected ray. You can put it anywhere, here or here. The next one, if it goes through F, if it passes through F, then it goes parallel to the principal axis. I'll use the other color here. Goes to F, then it goes parallel to the principal axis. Okay, so the rays, the reflected rays meet here. Don't forget to put the arrows. Okay, this is the incident ray, and this is, we have the after reflection. So exactly below you have to get. Okay, so this is your image, which is inverted and which is formed at C, So we write here B dash, A dash. Okay. So we'll write all the 3 points here. Position of image, at C. Then one, size of the image. Now you'll observe that it's of the same size. You get of the same size. Look here, my object was 1.5, and here is almost the same size. The third one is the nature of the image. Since the image has formed in front of the mirror, it is real and inverted. If it's real, it is inverted. Okay, right here MN, the aperture. Okay. So that was the position of the object at C. We'll do the fourth one. The fourth position of the object is between C and F. Between C and F, that is the center of curvature and the focus. Let us draw the principal axis. I take 6, this is my C, the center, draw the mirror. Concave mirror, inner side is reflecting and therefore I shade the outer side. Now I have to mark the focus, 3 centimeters and 3 centimeters here. Now the position of the object you have to place between C and F, center of curvature and the focus. So keep it roughly between C and F. Don't take the object too big, don't take it too small. So roughly I take it 1.5. So the first ray goes parallel to the principal axis, gets reflected and emerges through F. Okay. The next one goes to C. Let us draw the next ray. The first ray goes parallel to the principal axis, it emerges through F as usual. Next one goes to C and it emerges through C itself, goes along the same path. So it has to touch the head of the object, the center of curvature and the mirror. So try to connect all these 3 points, 1, 2 and 3. Okay, so it touches here. So extend this principal axis a little bit so that you get drawing of the image. So the reflected rays meet here. So this is the image form inverted. So what do you write? A dash, B dash, and this is your A object AB. Okay, this is your MN aperture. So let's write. So revise again. It goes. The first ray goes parallel to the principal axis. After reflection, it passes through F. The next one goes to C. It comes back along C itself, and both the reflected rays meet here in front of the mirror itself, and what you get is the enlarged image. So to get enlarged image, you have to place the object between C and F. So position of the image, it is beyond C. So it's the opposite. If you place it beyond, if you place it between C and F, you get it beyond C. And the previous one, what we had done, the second position, if we have, if we place the object beyond C, we get the image between C and F. The size of the image is enlarged. Enlarged means big. Third one, nature of the image is real and inverted. This was the fourth one. Let's go for the next one. The fifth one is the position of the object at F. So we begin by drawing the principal axis. Take the same measure, 6. not the C. The inner side is reflecting, concave mirror. Mark F. So the object is placed at F. A, B. A and B. Okay. The first ray goes parallel to the principal axis. It emerges through F. The next one, so as usual, it goes through, passes through, parallel to the principal axis and emerges through F. The next one goes to C and passes back along the same path. So, you have to connect C, the head of the object, and the mirror. Okay, I'll use some other color for this. So, you find it goes to C and comes back along the same path. So, you observe here they do not meet, they go parallel, perfectly parallel. Is that clear? And therefore, the position of the image, we cannot draw it here, it is not seen here because their rays go parallel, and hence it is seen that the image is formed at infinity. So, it was just the opposite. When we drew the object at infinity, we were getting the image at focus, and if we place here the object at the focus, we get the image at infinity, and this image is highly enlarged. So, first one, the position of image at infinity, size of the image, it is highly enlarged, and the nature of image is real and inverted. Let's go for the next one.